Okay, number 3. So it says for each function, the one function below, find inverse of f. Okay, so here's our f of x. This is equal to 11x plus 7. Okay, what I'm going to do is just kind of rename some variables. So this one in particular, I'm just going to call it y. Okay, and then so y is equal to 11x plus 7. And what we want to do now is solve for the dependent variable. And in this case, that would be our x. So we're just going to solve for that to get it by itself. So we're going to subtract 7 on both sides. So we get 11x is equal to y minus a 7. Okay? And then the last thing, we're just going to divide by 11. Divide by 11. And we get x is equal to 1 over 11 times y minus 7. Okay, so once we get this notation, because they say they want our input to be in terms of x, we can kind of just change like I said, you can kind of interchange or swap out the variables, the variable names, that is. Okay, so we're going to take this guy and make it into f inverse of x is equal to, we're going to keep everything in the same place. Okay, so 1 over 11 times whatever our input is, so that in this case would be x, and then minus 7. Okay? Okay, and so on the next slide, I'll show you a second method of a way you could find an inverse of a function. Okay, so here's our original function again, and like I said, I'm going to be explaining another way how to do it. So let's say, again, we're just going to rewrite this as y equals 11x plus 7, and instead of doing it the other way, like we did before, we solved for x and then switched variables at the end, which might have been a little bit confusing. So instead what we're going to do is I'm just going to say, okay, so the first thing you do is switch your x and y. Switch your variables, basically. So now we'll have x is equal to 11y plus 7, okay? And now you solve for y again, okay? Now solve for y again. Solve for y, okay? All right, so if we solve for that, we actually end up getting the same thing. So y is equal to 1 over 11 times x minus 7. Okay, and once we arrive here, because we made the switch in the beginning of our variables, we just keep this and call it f inverse of x is equal to 1 over 11 times, in parentheses, x minus 7. So we got to the same conclusion. Here on the second method, we just switched the x and y first, like as our first step. Okay, and then we just solve for y. Okay, whereas in the other method, we solve for x. We didn't do any swapping yet. We solve for x. And then at the end, once we have x alone, then you switch the variables. So whichever one you want to do first, just find a method that you like more, and then stick with that, okay? Bouncing around in between both of the methods can be a little bit confusing, okay? Alrighty, here is number 4. So we say if f of x is equal to x cubed minus 5, and g of x is equal to the cube root of x plus 5, we're going to find two things. So part A, we're asked to find f of g of x, so the composition of f and g, right? And then part B asks us to find the composition, but in the other way, so g of f of x. All right, so let's work on part A first, okay? So we're going to take f of g of x. So that means that our whole function g is going to be the input of f, okay? So let's just write kind of the outer shell of f, right? So this would be input to the third minus 5. That's what f of x means. Okay, and now in this blank space here, we're just going to plug in g of x, whatever that is. So that would be the cubed root of x plus 5. Okay, so now we just simplify. We see that the cube root and the cube power cancel out, so we just get x plus 5 minus 5. Those ones cancel out, and we just simply get x. That's kind of funny, right? But it's nice that it simplifies like that. So now let's work on part B. So now we're going to do it the other way, okay? So now the function f of x is going to be the input of g. So let's write the outer structure of g. So this would be the cube root of something plus 5. And that something is going to happen to be our f of x function, so this guy up there. So we're just going to plug in x cubed minus 5. Okay, so we see the negative 5 and the positive 5 cancel. So we get cubed root of x cubed. So again, those ones cancel, and we get out an x. That's really funny, isn't it? So what this means is that, well, since both of these guys are equal to x, that means that each composition gives us back our original input, right? Like once you put it into, we have our original input, we put it into g and then into f, and we get back to our x. Okay, same thing with this one. If we take our original input and put it into f, and then take that result and stick it into g, we get our original input. right? So this means that f and g must be inverses of each other. Inverses of each other, okay? Okay, so that concludes our practice problems video on inverse functions. I hope that helps, and good luck on your homework.